Uh, Welcome everyone. Thank you for coming both in person and online to this AI Fund. Today we have Masha Vladimirova from Criteo in Paris, who's going to talk to us about fairness in online systems. Masha, like myself, is a statistician turned ML and AI person, and she's extremely talented. We met at when I was a PhD student, and she was a PhD student as well. So without further ado, the floor is yours.
Thank you. So I'm staying here, as I was told that the microphone is mostly capturing here better, and the camera here as well. So I'm sorry I'm not in the center. Thanks a lot for invitation. I hope you will learn something. It will not be very deep technical presentation, but maybe more on the motivation and sharing some information that we learned in the process. And maybe firstly, I was thinking like how to start, but it's my first time in Manchester. And I was thinking maybe I would start with who I am and how did I get here. And so I was born in Penza. Okay, it starts very far away, and maybe you're wondering what is Penza. Well, Penza, it's a city which I usually say not far from Moscow. But you can see it's 645 kilometers, which is 412 miles approximately, which is kind of the distance from London to Edinburgh. So maybe for you it feels like not far from Moscow, you know, but it's actually really close on the distance in the scale. And so I was when I was in the university, I was quite lucky because then I moved to Moscow and I did my bachelor studies, and I was one of the ones very close to home. So I could travel just 12 hours night train, and then I could get home. And then I moved to Grenoble, from Moscow to Grenoble. I was very happy with this because before it was quite gray. And so in my mind, I moved to the place which is very sunny in the middle of the mountains. So very bright. And this is how the picture changed in my mind. So in Grenoble, I was doing my master, then I did my PhD, and then I did my postdoc there. And I was working on theoretical deep learning, mostly on Bayesian neural networks. And so we analyzed the differences between Bayesian and frequencies neural networks and some equivalence between them. And then I moved to Paris. So I started working in industry, and currently I'm a senior researcher at Criteo AI Lab. And Criteo is doing everything related to digital advertising. And so they're mostly working on causality, on fairness, and on topics around generative AI. And so the move from Grenoble to Paris was a bit painful because it's back to gray. Well, I expect here it's not much different than in terms of gray sky, but when you're used to sun already, then it's kind of, you know, you need to sometimes adapt. So I'm still in the process of adapting, but the city is very beautiful, so I'm still pretty happy. And well, that's it. This is the story of my life. And then I was traveling a little bit, doing some research visits, including Duke University. Okay. So now we move to the main topic of the presentation, which is fairness. So I will start with the definition of fairness, what it is, why do we need it, why do we care? Then what's actually the problematics in advertising or online systems in general. And then I will try to show you some solutions or what we're currently doing and how it is impacting the overall system. Okay, so let's start. What is fairness? Well, when we look at the dictionary, fairness is the quality of making judgments that are free from discrimination. Okay, what it means actually what we need is we need a definition of discrimination, because the notion of fairness is based on the notion of discrimination. Then we check the definition of discrimination, and we see that discrimination means distinguishing between two or more people or things. So it doesn't sound really bad. And here there are also examples that discrimination isn't always a bad thing. So like you have to use discrimination to tell a good restaurant from the bad one, you know, so it's not this bad. And but then when we usually talk about discrimination, it usually means that we treat some people better than other people's based on some features of these people. And so why is it bad? It depends on several things. So first of all, the context. Like, for example, with respect to the jobs, we don't think that some features of the people that maybe people don't really choose, like the skin color, should affect how they get into the jobs. And so this is our beliefs. It's based on our beliefs. And maybe it was not always the case. Before, it was perfectly normal that some people were only working as slaves because this was the belief that this was they were supposed to do. And then these beliefs were changing. So in the end, what we need our moral compass. We have our ethics, moral principles that change over time. Then we have the notion of discrimination, which is based on these moral principles. And it is only bad in some specific context, for example, with respect to the jobs, and with some specific features. For example, skin color, your sexual preferences. So these things which are important, they change over time. They based on what the community thinks. Of course, they also are different in different countries because all the people have different problems everywhere. And so we have to deal with this. And since we are ready to think that, okay, we don't want, for example, discrimination at the job, so we work towards it and try to improve the situation. And so the thing is that it's indeed a very complex subject since it's based on moral principles, and even among different countries, people cannot agree what it actually means. So here is an example of translation of the fairness notion, which is what's translated in EU Act or in the GDPR. It's actually in GDPR. So it was translated in different countries. And so each country translated it in their own way, and then it was back translated into English. That means to see the actual word which was translated. And so we could see here that fairness means for some people is something reasonably, correctness, justice, equity, loyalty, objectivity, and so on. So all different notions. And in English, they're all different, right? So it's not something exact. And even people between the countries and the government cannot really agree on something. And so it adds the complications to the topic. Okay, so in the end, we have the following challenges. Firstly, we need to agree on moral principles, so that usually it's done like in democratic countries. We have we have elections, so we vote for specific people with whom we agree on moral principles, and so they act for us. Then we have law enforcement, so these people decide which law exactly to do. Then, based on this law, we choose the specific definitions which are important for us. So, okay, we work on the fairness. So there is a precise definition what we should achieve. And then we translate it into mathematical terms. So we create metrics which would correspond to these notions. And then we create benchmarks with respect to these metrics. So in order to improve the models, the systems, and so on, so we create the benchmarks. So, and we have challenges at each step, but we need to be aware of it. So in the end, what we need is accountability, that everybody is agreed moral principles, they want to improve their lives, and so we're all accountable for this, and at each step we try to improve the system. Then we need transparency, so we need to know how the systems work, so where we could account the fairness or unfairness and so on. And then we need to do research to dig deep into the topics and to understand what we're actually missing out or whether there are errors possibly or not. So, and in AI models, the unfairness can appear in different steps. So if we translate it from the general work perspective, then we have in AI models, what is important is the data, is our assumptions on the model, and then the training process. And all this is like all induction bias, which results into some output. And this output can affect people. And so firstly, when we start with the data, so as we said, that our beliefs change through time. So, and this actually can be seen in the data. So now, for example, there are more men in managerial positions than women, and this is because of the previous beliefs, and so it still has an impact now. What we try to kind of reduce the bias here. And so still, you can see it from the data, and then our algorithms train on this data, so they learn this bias existing in the data. And this is called historical bias. Then we have data preprocessing, where we have some selection or representation bias. Maybe it's based on the algorithms that try to do this. Maybe it's based on some humans that try to do the preprocessing and so on. Then we train the models, and the models can learn this bias present in the data, or it can have the specific bias that it was induced by the induction bias that is present in the model. So maybe the model react differently on different features. And so this is algorithmic bias. And then we show these models, the outputs of the models to people, and then the people make some decision making. And so they might interpret the models differently because they have their own beliefs, and they have their own judgments in their head, how they see what they see. Okay, so they have the whole system, which is complex. And so we cannot, when we train AI models, so when we try to do something, we cannot really affect the historical bias because this is not done by the model itself. We try not to increase it, but at least we try not to make it worse. So the historical bias is changed through education, telling people that this is right, or what is wrong, what is right, and so on. And so what we can actually affect is the selection and representation bias and algorithmic bias. And so this is the goal of everybody who is working with AI, the deployment or creation of the models, that we try to reduce these two biases. And so I like to think about the unfairness from the causal perspective. So when we say that there is a causal effect, so that means X is this arrow to Y, that means that X causes Y. And so here to introduce some notations, X, for example, user features. In terms of advertising, it would be some browsing history features. Then A would be so-called protected attribute, a feature we do not want to discriminate upon. Then we have a true output, and then we have predicted output. So in this system, the predicted output can actually affect the final output. For example, here, the final output could be that the person would apply for a job. And the predicted output would be the probability of the person to apply for a job. And this probability would affect, for example, for us, if we show an advertising or not to this person of this job. And so in this case, if the person saw the ad, that they would, this person would likely apply, at least having high chances to apply than the one who didn't see the job and the job offer. And so in this case, our predicted output can actually affect the final output. And so, but not necessarily. So maybe the person would see this job ad separately somewhere else, not for us. And so in this case, for example, X causes Y means that the person applied for a job. Then we have Y affecting our predicted output. This would be the direct unfairness, because we take the decisions with predicted output directly based on the protect attribute we do not want to discriminate upon. Then we have indirect unfairness, which comes through the X, because the protect attribute can actually affect other features. There could be some correlation between these features. And so we, it was a mixed change in options. Well, there could be some effect on this, on our protect attribute. And then the other things that comes, like, for example, if a person makes decision directly applying or not, just because this person is man or woman, this would be the prejudice and so on. So this is an option. And this is from the causal perspective, it's that the unfairness that comes from the data. And from our perspective, that the algorithm actually affects the final output. But then there is another perspective, then this output also is taken into our prediction algorithm. So it's like the label that we try to learn. And so there is a kind of, it's a sequential process. So first of all, there is the data coming to us, then we affect this data, and then again the data coming to us. So, and this is from the perspective where we already trained the model. Okay, so in the end, we have several cases from the fairness perspective. First one is unfairness, when the protected attribute directly affects the output of the algorithm, and which can be done just by having this feature available among other features that we train the model. Then we have so-called fairness for unawareness, when we do not use this feature, protected attribute, as a feature of the training, but it can still have an impact through other features. And this is usually what is used in most of the production algorithms that should not be discriminative based on some features. And this is like the basic solution, which can be still unfair. And then we have the total fairness, which would be from the causal perspective to close the path from A to Y hat. And this is usually, so from the causal theory, it says to have the mutual information between Y hat and A conditionally on X equals to 0. So, and this would mean literally we do not have the path from A to Y hat, so we close it. Of course, to force the mutual information to be 0 is not straightforward when you train an algorithm. Okay, so and then we see how the unfairness can pass, how the feature then attacked, and then the definition of the fairness from the causal perspective is called counterfactual fairness. So what would have happened if we had changed the feature, the protected attribute, and keeping all the other feature fixed? This is what we do with the do operator. And so the perfect fairness would be that the output of our prediction stays exactly the same when we change just this feature. Of course, in the real world is not possible, and we cannot also ask a person to change the gender and not changing anything. So this is the perfect definition, which is impossible in real world. And then the other definitions are just approximations, and they might even contradict each other. And this adds to the complexity. So, and we usually focus on demographic parity, which just tries to do the distributions of the outputs to be exactly the same for different protected attributes. So in the end, the unfair model would have distributions of predictions quite different, and the perfectly fair model would have the distributions exactly the same, which is the group notion fairness definition. That means that we try to be fair for the group, but individually it still can be unfair. But this is what is widely accepted, especially in the laws. So they consider not individual unfairness, but mostly the group fairness. And so when let's go to advertising. So as I said, the advertising might affect, for example, in terms of job advertising. And so if you browse on the internet, you might see some job advertising. And the question is maybe not the fact of seeing job advertising, but more importantly, which exactly job advertising would you see, like the senior role or not senior role? And so in advertising, there are several features that actually affect what you would see. So for example, there is a context, which means on which web page you are currently. This information is coming further to the people who try to put the ad on their web pages. Then there are the user features that usually come from the cookies, if you accepted them, or just the general information, which is based on what exactly you saw on the web page. And so these features is like browsing history, which web pages you checked, or where did you go exactly, which products you checked, and so on. And then there are, of course, the job offer descriptions, and all these, they affect which job ad would you see. For example, team lead or office assistant. And so if we take directly gender among these features to try to predict which seniority level of the job you would see, of course, this is unfair. As we saw, it will have direct impact because the model will learn directly a weight to put on this feature. But the gender feature can affect other features. So gender feature, it means that your gender can affect what you actually see on the internet. For example, statistically, like men browse more sports web pages. And from this case, maybe the algorithm can approximate that if you browse more a lot of sport web pages, then we would suggest you the team lead position. Or the woman buy more women clothes. Perfectly fine. Statistically, this is the case, and there is nothing discriminative on this if we show ads of women clothes to women, because statistically women are interested in women clothes. So this is the physical difference, which is not discrimination, because discrimination based on the context and on the features. And so, but if the algorithm tries to approximate this and show the specific job ad based on these features, then it would be discrimination, but this is indirect discrimination. So this shows that feature of fairness for unawareness could still be unfair. And so if I consider fairness ladder, our goal would be the following. So the 0 level, it's complete unfairness when we take the, for example, gender feature into our prediction and we try to predict the seniority of the job ad. So if this is we're not doing because even by law it's not possible. Then there is the feature for unawareness when we do not use this gender feature, and so we're currently here. And like a lot of companies, they're currently here. Then the second level would be to have fairness in prediction. So to have the output perfectly fair, exactly the same for man and woman, the seniority of the job ad for man and the seniority of job ads for women, exactly the same. But this would not change the external unfairness. Because to correct external unfairness, we need something like which is called positive discrimination. So it's still discrimination based on gender, but it's like the current gender is biased, and so we do the opposite bias to compensate it. Without this, we keep the same level of bias because we do give exactly the same opportunities to men and women when more men have the opportunities. So in the end, still more men stay on the job, on these senior position jobs, and so it doesn't compensate the existing bias. But the companies cannot do this. There are some exceptions, and this is usually done by the government or some educational programs or some specific things. For example, like women less applying for promotion, and so, for example, companies can send the emails, oh, maybe you want to apply for promotion. So kind of these reminders, but send it to everybody, but not discriminating way. And so like little reminders. This actually works. And so in the end, our goal is to be at level 2 and not to correct the whole external unfairness, but at least be there. And for this, we need some bias reduction methods, because otherwise the models learn the bias that exists in the data. Okay, and so it's also in the recent EU Act that like targeted job advertising now is considered as a high-risk system. So at the same level as using biometric data, which is quite high, but not the prohibited risk, which you cannot do. And so when you are in a high-risk system, you have to consider what exactly the bias, you have to measure it and mitigate in case it exists. So there are several complications about this, but I'll talk about this later. And so, so Criteo, it's our company that also signed a fairness pledge that was organized by ABM a few years ago that like said, okay, we will actually measure it and investigate. And the brand very fresh news from yesterday that Facebook was found discriminating by gender. Well, it was actually the research done 2022, 2023, but in the beginning of 2023, they released a new algorithm which was mitigating bias, and they said, okay, we don't have it anymore. But people did some experiments and they still found that it actually does. Okay, so it's not that straightforward. Meta is still biased, for example. So they exist bias in the system. In the end, we need to investigate it because we have our moral principles, because we want to avoid legal charges, because the quality of the services might decrease, and because it's important to anticipate as well, even if currently it's not yet there. So UX is very fresh, and there are now still law enforcements. So then what do we need to do? Well, firstly, we need to fix the product attribute. Then we need to understand in the whole system how it appears. And then we test the different techniques, and that's it. Okay, so the problem is that for us, the system is very complex. So still there is this bias utility trade-off, because if your algorithm is perfectly trained on the historical data, then it learned the bias. And so already if you try to debias it, of course, you lose in the accuracy. And so you lose in the utility, in the final utility. Well, in reality, it's not always the case, but just because sometimes the data is very noisy, and so the algorithm cannot really learn all the bias existing. So sometimes it can actually make it better. And then, so our main problem is that we do not really have access to protect attribute. So, for example, when you browse on the internet, you don't really say everywhere what is your gender. And we work on the open internet, so on the information which is publicly available and only for cookies. So there is no such an information of your gender. And in the end, since we do not have this information, what we can do is that we try to approximate it. And as I said, based on these features, we can actually extrapolate something, though we are not sure if it's exactly the case. So in the end, what we did is that we said, okay, but then let's check the products that we have. So the products can have gender. For example, woman, the dress would be a female product, and male skirt would be, or male shirt, sorry, will be a male product. Okay, and then we check the user timeline, and the majority of the product would define the gender of the user. Well, quite straightforward. The problem is that so there is many more female products somehow, and so we need to do some discount, and so we did some discount to have kind of a 50-50, around 50-50 world representation of the internet users, and so this is the proxy. And we consider binary, but we also had neutral, which is like not very much difference between the products. And so it is the proxy. It's not perfect, and we do not have a way yet to verify if it's somehow closer to the reality. But our goal was to check it. Well, even for this proxy, we do not want to discriminate now. Like, why would you decide that the female products, that means that we need to show like lower position job, right? So this is the idea. And so then we studied in the whole system. And for this, you need actually to know how the system works, which is also not straightforward. When you come as a researcher to a huge company, you need to study it in detail. So now let's study how the advertising works. So when the user enters the web page, there is this tiny circle which is loading the page. And in this very milliseconds, they're happening the whole several recommendation systems. So first of all, the user enters the web page. If it's a web page that has banners where they want to show ads, so to monetize their blogs, for example, then there is a company who organizes auction for these biases. This company sends the request to all possible participants that if they want to participate, and there happens the first bidding. And then the winner wins, and the winner shows the display of what they want to show. So usually what happens firstly from the company side that participates in these auctions, they choose campaign, because how they paid is they have clients. So, for example, there is Nike, who is paid for us to show show shoes ads, and there is like some job advertising company for whom we show job offers. Okay, and in this moment we choose for whom we will participate, because we have contracts where we get the money. So And this process is called campaign. So there are different campaigns, and for example, either Nike campaign, either some job offers campaign. So in this campaign selection, what we actually could have selection bias. So for example, we have the internet population that we computed on all our users that we have. And it's like we have 53.6% of female users and 46.4% of male users. So this is based on this gender proxy that we defined. And then in this process, for example, we choose that we show 39.2% job campaigns to female profiles and then 60% to male profiles. So is it bias here? Is it a definition of the bias in this sense? Because we just choose between job advertising and Nikes, which exactly job campaign you want to show. And according to the definition of the bias, it is not really the discrimination here. Because what we discriminate, we choose good products, the one that affecting, like for example, job ads. But here we just show campaign. It's not even the product yet. We choose the campaign, and the product would happen later. Okay, so then further there is the bidding, which with this campaign that we chose, we computed approximately how much we're ready to bid, and it would be the money we're paying. And then in this moment, there happens several things that we notice. So firstly, the woman profiles are price demographics, so they cost more. And then because of this, the competition, so everybody pays more to female profiles. And so you cannot really say, okay, I will pay you also more for male profiles, because there is the whole system which it will be not working for you, because there is also the feedback loop that tries to optimize the market. So this is there is equilibrium on the market, so you cannot just decide, okay, I will pay more for this people. So why women profiles are cross demographic? Well, there are more female products. First of all, so maybe these effects, plus also we saw that female profile clicks more. So you want to have clicks on the job ads, so they cost more. And what to do with this? Well, it's not like you can force a man to click more. So this is like the whole system is like this, but this is with respect to the gender proxy. So we're not really sure if with respect to the real profiles, it's the same. And so because of this, in the end, we could have an algorithmic bias. So here, for example, in this process, when we won the auction, there happens another recommendation system where we decide which product to show. And here, there could be the bias, because we could decide to show senior job ad or not senior job ad to more male profiles or female profiles. So even we have more information about the male profiles, we could still be good in terms of the ratio with respect to how many senior job ads and non-senior job ads we show, right? So here, actually, it is not really the case in terms of the numbers. So you can see, like here it's a subsample, so we would see exactly the same number of job ads for female and male profiles, and almost the same level of clicks. Though even more clicks for the non-senior profiles, and while the senior job ads not clicked are showing many more to male. Well, it's a bit complicated to see, but this is kind of says that maybe there is some bias. And actually there is, so we show that there is like 20% more of job targeted campaign targeted towards male profiles and female profiles. And this means just that there is representation bias, right? So it's like in the data, we have many more information about the male profiles and female profiles. But then we see that actually the senior job ad, they're showing more to male profiles and to female profiles by 3.5%, which is not huge, but it's like this little bias. And then but the difference between clicks is not significant. And so what it shows is that maybe there is a kind of some bias amplification happening, because the difference between click is not significant, but since we have more information about the male profiles, it's just the algorithm decides, okay, I will just show more senior jobs to male profiles, and that's it. Okay, and so what we need to do is we need to see how to mitigate this bias. And what usually happens, so as I said before, to mitigate the bias, so here the plot is different. Here we take y as the feature that we have in the data set, so the label that we want to learn. So this is like before rolling out the algorithm, we have the predict attribute, we have all the features of the users, and then we have the label that we want to predict. And so all this is used for the prediction. So now we want to have the mutual information between prediction and A to be 0 given both X and Y. So because this is the information we have. As I said, it's not straightforward how to approximate all the mutual information. So there are some ways to try to get it closer. And this is how we would block the path. And to do this condition dependence, so we usually add some penalty term. So when we learn algorithm, we have the loss function, and plus we add the penalty which would block this path. So it's kind of we force the algorithm to find the trade-off between the accuracy and the or like some utility function and the fairness. And we hope we will find the best trade-off. And so there are different penalties how you could approximate. So you need just approximate mutual information. So we did these experiments, and all the statistics that I showed, it was actually from the data set that we released. It's based on our real data. So of course it's some samples, so it's not exactly the same statistics inside. But this was the data set and the experiments. And so we also suggested some other utility metrics which would take into account the fact that we'll have the representation bias. And so taking into account all this, we tried to find the best trade-off. I didn't show you the results, but it's actually, so we can get a little bit better, but it's still far from like zero fairness and so on. Zero unfairness. So we, with this penalty term, we managed to make it work. First of all, the algorithm is, the data is quite complex because it's heavily unbalanced. It's high dimensional, so there are like 50 features around, and 0.7% of the positive label, which is very few. And so you have to deal with this, and to make it work for female and male profiles to have the same seniority of the job. So, and in the end, and also the problem was that when we started working on this, we realized that all the work in the field is done on the very tiny data, like 50,000, 100,000 maybe. So there is, everybody's using the adult data set and so on. And we have millions of rows, which is really not comparable. And so all the models that work now with this approximation of like mutual information approximation, they just are not scalable. And so this is open questions how to properly actually make them work in large dimensions. And so we did a few experiments, we did some baseline experiments, and we managed to improve a little bit, but it's still an ongoing work. Okay, so what we did, we analyzed step by step. We actually open sourced the data, and we did some benchmarking, and we chose some proxy. And so the problem is that we still need to find this perfect trade-off between fairness and accuracy, because the current systems are not perfect. And so current systems are not perfect because we know are not perfect, but also the thing is that all the work is done on the quite small data. And so you need to put more efforts on trying to make it work better. And you need to actually keep the system kind of working, innovate, but to be safe. Then there is also a question on the privacy, because okay, here we show the work that it's like we improve something, but for only proxy, and we do not have real information about the product attribute. And so about this, it's not that straightforward. because sometimes privacy can improve fairness, but also sometimes it's the opposite. And you need to do studies on all the different data. And current theoretical research is on with a lot of assumptions on the data and on the models themselves. So in real world, we don't have these easy models. And so this is still ongoing work on how to address this. And also, so kind of our goal is not to make people scared about advertising, because when you say you work in advertising, like, oh, so bad. But actually, it's not that bad. And we try to make it work better. And I mean, everybody, I don't know how about you, but like, I saw a lot of things that I really like the concerts and so on from the advertising. And so it's kind of working, and it makes like on the system, it's also making some things still open. I mean, it helps people to survive, then why not? And there are the questions of moral principles of the whole system, but these are the principles. And in the end, we have the problems of the fairness definition, as it's still evolving. Individually, everything is still unfair, because if you want to make it fair, there still will be this trade-off with respect to individuality, sorry. And so this you need to, maybe there could be other definitions of fairness. Already the fairness from the worst case scenario is not that bad. Like, you expect the algorithm to have some worst case scenario, and you accept some trade-offs, which not necessarily mean exactly the same trade-off with having, for example, demographic parity. And so the notions are also evolving, and so you need to keep track of this and to see what people doing around. Yes, and that's it. Thank you.